this is another important concept in terms of estimations of the volatilities. Very much important in the risk management space again, because the risk keeps changing on a day by day basis. If the risk keeps changing on a day by day basis, how do I compute the today's risk, or how much did the risk change compared to yesterday? That is what is coming out through the estimations of the volatility. Similarly, correlation. Until yesterday, the relationship between Dr. Reddy's and HCL is this much. So today, what could it be? Because this minute aspects play a very important role in your portfolio hedging processes, or even in your trading processes, because probably you may take that advantage of those minute kind of differences itself today on large volumes, and thus exploiting the differences. Those are some of the things which heavy quant trading oriented companies typically get into. They build models on all these platforms, and based on that they get into the trading processes. So the same, probably will use the same data again for estimating the volatilities using the various mechanisms. We in this chapter we discuss about two mechanisms of estimating the volatility. One is called as an exponential weighted moving average mechanism, EWMA model, and there is one called Garsh model, which uses the definitions which we have covered earlier: autoregression, conditional heteroscedasticity. Using these two kind of stuff, it actually builds a model to estimate the volatility at each of the periods. Now, if I have to do that, the first assumption that is going there is, the first thing, if I do the estimation of the volatility, what it says is you can do it using the historical data. Using this data, I can estimate the volatility. Probably, as we have done, take the standard deviation of all these days, right? If I take the last 250 days, whatever I have taken as the average of that, the standard deviation of those 250 days is what is my volatility, is my daily volatility, right? And probably if I want the latest volatility, instead of taking the average, see, standard deviation is nothing but the average of the square of the deviation. Variance is nothing but the average of the square of the deviations from the average, and taking the square root of that has given me my standard deviation. So what this mechanism says is, if at all you want to find out for last 20 days or 30 days, for the last 30 days what has been the volatility, right? What it is saying is, let's say I'll not go with the entire data, I'll take the last 30 days, right? For the last 30 days, what is the volatility? I can take the average. If I take the average for the last 30 days, okay, the average returns is to the extent of again 0.001, very close to 0. And the same logic, if I put it to this company, the average return again, even in this case also very close to 0. Now what it says is, the standard deviation is, how am I getting the standard deviations or the variance? I'm subtracting each and every return from this average, doing a square, taking the average. So if I'm taking the last 30 days, what are those last 30 days for me? These are the last 30 days. So probably from this date, right? If I'm considering from this date, the normal model, what I'm doing to estimate the standard deviation, apart from the direct formula, If I'm doing a estimation of the standard deviation, what is that I'm doing? Each and every value, I subtract the average from it and take the square. Each and every value, I subtract the average. This is the way we compute the standard deviation and the variance in our data. First, we find out the mean. Each value, we subtract the mean, take the square. Okay. Each value, I have subtracted the mean. Each value, I have subtracted the mean and taken the square. Okay. Each value, subtracted the mean and taken the square. And I can take the average of those things. The average of those things is what is nothing but my standard deviation or variance. The average of those things is the variance. So, what is the variance for me? In this case, the average of these numbers is what is my variance for the Dr. Reddy's, and similarly this is what is the variance for the HCL Tech. Take the square root of these two, I get the daily standard deviation. So the standard deviation, daily standard deviation is 1.8% for this, and it is around 1.72% for this. So if I'm looking at it from a standard deviation standpoint, I may say that HCL Tech is slightly less risky compared to Dr. Reddy's or vice versa. Right? Now, how do I estimate this 1.8? Is it forever? Right? From the calculation which we have done, it is for the last 30 days. So can I take the same number for tomorrow? Right? That is where I need an estimation model. Right? So the standard deviation, okay, here it is showing 1.8. Now all I want to know is whether the standard deviation is going up or falling down. What is the pattern in terms of the 30-day standard deviation across the period? And if at all I have to estimate the same, see, probably historically, if you want, you could very well talk about, okay, yesterday's standard deviation means I take it from here up to here, and I say this is the standard deviation as of yesterday for the last 30 days. So historically, if you want, you can easily calculate. But using that knowledge, if I want to do it for the future, right, in the future, when is that the standard deviation is going to go up? When is the standard deviation going to go down? Because there are so many instruments, financial instruments, that get priced based on the standard deviation in the data itself. Right? The options, very heavily they are priced based on the standard deviation. Some option pricing model is there, Black-Scholes model, which actually uses the volatility or sigma as one of the parameters in the formula. Now, what number I should take for sigma? Today if I take, it should be a different sigma. Tomorrow if I take, it should become a different sigma. Only then my estimates become more and more appropriate. Otherwise, it becomes a lot biased in my estimate. If I'm using the same sigma for 20 days, that is what a Black-Scholes model even says as one of the assumptions of the model. It assumes that the volatility in the stock is constant for 20 days. Today, it's a very weird assumption to make. Right? Something, the fluctuation is constant. It's not saying there is no fluctuation, but it's saying that fluctuation is constant for a 20-day period. We don't know, right? Today, the probably with the recent news bloating up, Probably the fluctuations may be much higher in either direction. When the economy is in a very stable state, the fluctuations could be pretty much normal. How can I use one single standard deviation for the entire period? Now, just to give you that thought, let's say I am looking at the standard deviation for this entire year. Instead of last 30 days, if I look at the standard deviation for the entire year, this is saying only 1.3%, whereas this is 1.5%. For the entire year, HCL standard deviation was more compared to Dr. Reddy's, whereas in the last 30 days, Dr. Reddy's standard deviation is more compared to HCL. Now, if I had taken one single number, probably I would have gone with a simple bias that HCL is more riskier than Dr. Reddy's. But if I am looking at the latest trend, latest data, I have to make a conclusion that Dr. Reddy's is more riskier than HCL. Now, the same logic can come into my way for the future also. The order may keep changing. That is where we are bringing in the estimation kind of models, the volatility estimation kind of models. So these volatility estimation models, what they are coming out with is, now if you see in this entire process, they are asking you to find out the returns. Given the prices, they ask you to find out the returns, especially the continuously compounded kind of return, which is log. Based on the log itself, log today's price by yesterday's price, they ask you to find out the continuously compounded kind of return. And what they are also suggesting is find out the average returns using that scenario and the standard deviation of the returns. And what it should come out generally, especially if your data size is very small, data frequency is very small, the time periods are very closer, you will see that the mean is very small compared to the standard deviation. And the mean is very close to zero in most of the cases. Especially for this returns kind of scenarios, you will see that the mean for a very small period, it's like for a very minute period, what is the average return? Almost zero, negligible. It will be there, but it will be negligible. From today, see, it's like, okay, from now to another 10 minutes, what is the return? Right, I am investing 100 now. Within another 10 minutes, how much it is going to become? Almost negligible. Probably it may become 100.000001. So it is almost negligible. So that is the first concept it drives with. What it is simply saying is, compute the continuously compounded, we'll do the step by step. Compute the continuously compounded returns, which we have already found out. Compute the mean for last such periods, whether it is 30 or 250, whatever I am doing with, I have computed the mean for those kind of periods. If the period is very small, daily or something, just like the example we have taken, you assume that the mean returns are zero. So, which means though the system has calculated this as the mean, take them as zero. Now, what is the way to compute the variance? Each number minus 0 whole square, which means each number whole squared is what you are doing. Each number minus 0 whole squared, right? Each day's return, what did we do here? Each day's return minus the mean return whole squared. Now we are saying if the time period is very, very small, you assume that the daily return is 0 itself. That's the first assumption these models are going out with. You assume that as 0, which means the variance, what is the way it is coming out? Every value minus 0 whole square, which is nothing but the return squared. Return squared is what is coming out, and the average of the return squared is what we are calling as variance. right? Earlier also we did the same. Each value minus the mean whole squared took the average. That is what we called as variance. Now the only difference we are bringing in this kind of model is take the average as 0, because anyhow they are very minute. They are very close to 0. So you assume them as 0 because we have to derive a model out of it. You assume that to be 0 and recompute the variance, which is nothing but the sum of